Let us see how loop analysis may be used to solve electronic circuits. So, here is a very simple electronic circuit. It consists of a transistor and then two sources and two resistances. So, this is a common emitter connection. So, in this transistor we have three terminals, the emitter, the base and the collector. The problem is to find out the current that is flowing in the base IB, to find out the current that is flowing in the collector IC, and to find out the voltage between the collector and the emitter V naught. But two quantities are given. One quantity is the relation between the base current and the collector current. So, the base current and collector current are related by this factor beta, which is given as 50. Then the other parameter we know is the voltage between the base and the emitter, which is equal to 0.7 volts. Now, how to solve, how to find out the current IB and how to find out the current IC and how to find out the current V naught. So, we could see that there are two loops here, one is the input loop and the other is the output loop. Suppose we take the input loop and write the Kirchhoff's voltage law. What we get is we start here and we come back like this. So, here there is a voltage rise, that is why it is minus 4 volts, plus there is a drop here, the drop is the base current multiplied by the resistance. The resistance is 20 kilo ohms, that is why we have written 20 into 10 to the power of 3, plus there is another drop, that drop is VBE. So, the total voltages, the voltage rise here plus drop here plus drop here. So, that forms one mesh. The second mesh is the output mesh. So, from this equation, because we know VBE, we can substitute that, which is equal to 0.7, this is given as data. So, we can find out IB as 4 minus 0.7. So, 4, if you take this to right hand side, it will be minus VBE, which is equal to minus 0.7. This divided by 20 kilo ohms, we get 165 microamperes. So, we found out from this equation the base current IB, which is equal to 165 microamperes. So, we found out this. After finding out IB, which is equal to 165 microamperes, we shall find out IC by multiplying IB with the beta. Beta is a given quantity, which is equal to 50. So, IB we have now calculated, which is equal to 165 microamperes. So, we get 8.25 milliamperes. So, that is how we can find out IC. But the conventional current that is flowing in IC is always taken like this. In the outer loop, if you look into, then there is a voltage rise here, that is why we have put minus V naught. Then the current is flowing in this fashion. Actually, the loop current is flowing in the opposite direction, that is why there is a minus sign here, and 100 ohms into IC, that gives the drop across this. Please remember that we have put minus sign here because the conventional current is flowing, IC is flowing in this direction, but however, our loop current is flowing in the opposite direction, that is why it is minus. Then there is a voltage drop here because the current is, loop current is flowing in this from rise to fall, there is a fall here, that is why we have put plus 6. So, solving this equation, we know IC, therefore, we can find out V naught. V naught is 6 minus 100 IC. IC we have found out already, which is equal to 8.25 milliamperes. That is why we have put 10 to the power of minus 3 here. So, we got the voltage V naught or the voltage across the collector and the emitter as 5.175 volts. So, solution of the problem we got it. We got IB equal to 165 microamperes, IC as 165 into 50, which is equal to 8.25 milliamperes, and then V naught as 5.175. If one finds the VBE and IC, we say that we have found out the operating point. So, this is frequently used, this analysis is frequently used in the transistor circuits and all that.
So, now that we have seen both nodal analysis and mesh analysis, which one should we use and when should we use?
Both the methods are equally powerful, but we choose one method depending upon the purpose. For instance, the problem is to find out the voltages only, we go for the nodal analysis, or if the problem is to find out the currents only, we use the mesh analysis. For computer computation etc., same problem if it is solved with a computer, usually node analysis is taken. For instance, in the PSpice, node analysis is taken. It also depends upon the network configuration. Suppose if more number of branches are there connected in series, then we go for the mesh analysis. If the branches are connected in parallel, we go for the node analysis. But as far as the learning is concerned, we have to learn both the powerful techniques, the mesh analysis as well as the node analysis.